All right, good afternoon, everyone. Welcome back. So the next speaker is Davey Shafik. David is a developer, works for Akamai Technologies, and he's going to teach us about performance and user experience.
Good
Thanks.
afternoon. All right, so my name is Davey Shafik, not David. My mother still calls me David, but that's, none of you are my mother, I hope. I am a developer. I'm an author. I'm an open source contributor. I do a lot of open source work. I am the release manager for PHP 7.1. I did not realize that was a 3-year commitment when I offered, but there you go. And most importantly, I'm at dshafik on Twitter. You may notice my accent is a bit fluid today. I am British, I live in the States, and y'all will convert me between both. So if that happens, I apologize. We'll see what happens. I do work for Akamai. We're the world's largest CDN. We do some really cool things. Check out developer.akamai.com. All right, so I always mention mental health prompt. This is a project that I helped start, which gets people talking about mental health and technology, which is a really, really serious issue. So check out mhprompt.org when you get a chance. All right, let's start with why performance matters. Amazon, I know they're not as big here as they are in the United States, but pretty popular store. They found that they lose 1% of revenue for every 100 milliseconds that they run slower. 1%. Which means in 2014, based on their revenue, they would have lost over $1 billion Australian dollars, which is 16.3 cents for every single person on Earth, or $49 for every Australian citizen. That's for every 100 milliseconds. That's kind of a big number. All right, let's look at others. Google. They found that being half a second slower meant they got 20% less searches, 20% less engagement, half a second. Bing, very popular. 2 seconds slower, they lost 4.3% revenue per user. GQ, popular magazine, they cut load time by 80%, and they found that their traffic went up by 80%. And time spent per session was up 32%. That's pretty impressive. A few others. Walmart found that a 1-second improvement led to a 2% increase in conversions, so sales. Etsy found that by adding 160 kilobytes more imagery on their mobile site, they got a 12% increase in bounce rate. So people coming in and leaving immediately, 12%. Staples, big stationery store, 1-second improvement, they found a 10% increase in conversions. This is why performance matters. So, conclusion on that, users can perceive tiny changes in performance, and it's actually as little as 14 milliseconds. 14 milliseconds. And slower sites make your customers less happy. This is proven time and time and time again. Less happy, poor user experience. Now, you may have noticed, if you were paying attention, that my slides have been getting increasingly slower by exactly 100 milliseconds a slide. I noticed it about 8 slides in. I don't know when you caught it. But I just wanted to prove that 100 milliseconds actually is a really long time. And generally, the thing that we go by is 10 seconds. That's the magic number. If you can get it in under 10 seconds, then your users, you'll keep them, you'll be happy. This is so not true today. On mobile especially, it's not true, which is ridiculous considering that's the more bandwidth constrained application. Right? So 10 seconds, just forget about it. You're looking more like 3 or 4 max. So who is responsible for performance? The answer is everybody. Everybody who has a role in producing your web experience has a role to play in performance. That means your designers. That means your sysadmins and DevOps people. That means your backend people, your frontend people, and browser vendors. All of us have a role to play. So what makes a web page? What are we looking at typically today when we talk about websites? 63% of the page weight is generally imagery. So anything you can do with images to improve performance, that's where you're going to get the biggest bang for the buck. Next up, we have a lot of JavaScript. HTML, not so much. CSS, fonts, that's getting larger, I think. Other, not really sure what that includes these days, but imagery is a huge, huge part of page weight. The size of pages is also going up. There was an article that came out probably about 3 months ago that we've now surpassed an average page weight larger than the entire binary for Doom, the original Doom.
Sorry, larger than what? Larger than what?
One more time?
Larger than what?
Doom. The game Doom.
Oh.
Yep. So 36% of websites are somewhere between 0 and 1 megabytes. 28% are in that larger than Doom size. It's about 1.5 megs. It fit on a floppy, remember. 15% no still, like it's still a large number, 2 to 3 megs. 3% at 8 megs. Like that's kind of ridiculous. But something else that's really, really important is the number of requests per page. You have to remember that every single resource in a page is a separate request, and that has overhead. And the largest number by far is between 51 and 75 requests to load a page. Still, even 15% at more than 150. There we go. All right, so if you're a designer, you have a role to play. Compress your images. If you don't, we'll do it for you. I'm so glad that's really hard to see sometimes on the screens. If you want fidelity in your imagery, you are responsible for compressing them. That simple. SYSADMINS, DevOps people, enable HTTP2. Like I can't state that enough. It's super simple, it's completely transparent, and it will help with that overhead of multiple requests that are happening for sub-resources. And you can do lots of other stuff. That brings with it encryption. HTTP2 requires TLS support, or requires TLS, sorry, to be supported in all major browsers. Check out let'sencrypt.org, completely free search, it's great. And they are free as in beer. They're automated. They're secure, transparent, they're open, and you can automate them with scripts and stuff. It's great. Highly recommend it. Use the cloud to scale based on perceived performance. Now, a lot of us who've looked at the cloud or work in the cloud will look at things like CPU usage or memory usage, and we'll scale based on actual resources. That is not always the best way to scale. We can have resources free, but because we're hitting, say, I/O locks or something like that, perceived performance is much, much less than the resources actually tell us. So this is not, I'm not saying to only scale based on perceived performance, but it's another thing you should be adding to your toolbox. So there's something called the speed index, which is a metric to inform you how fast your page actually is being perceived. And there is a Node script. Everyone can read that, I'm sure. So let's see. A little bit of JavaScript, I apologize. So pull in the web page test module. Go ahead and set up a test. So here I'm going to webpagetest.org, put in my key. That's actually the server that's going to be doing the test. Then I want to test my site, because why else would I put any other slide in here? And tell it to return the page speed. That's all I want. And then when it's done, I'm going to call this callback, check response, and I pass in the response. Now what actually you get back is a URL that you can ping until you get an actual result. So it just tells you this is where your result is going to be, and until the test is finished, you just need to keep pinging it. That's what this looks like. So we do a simple get on the report URL. We get all the data. The way JavaScript does ACB press is kind of yucky. Essentially, you have a response data variable. You just assign stuff as it comes in. On the end of the request, when it finishes, this is when we can actually process it. So we can say, parse the response. Is it a 200? If it is, then we've actually got our result, and we can look at both the first view and the repeat view speed index. So that is with and without cached resources. And then if not, we'll just go back through the loop again. So you can start to use this information to inform your scaling. Right? That's the idea behind this. So here's an example calling that. Just pings every 5 seconds, and then finally you get your speed index results, right? Okay, great. So sysadmins, DevOps people, you have a role to play. Backend developers. Who is a backend developer here? Imagine most. Okay, so this is going to apply to you. Cache aggressively. Yes, I do work for a CDN. This is my business, but do database caching. Like, you must. Whether that's in Memcache, Cassandra, doesn't matter. Put in some database caching. Full page caching should be also doing this. Again, Mem-based Cassandra, maybe you're using Varnish or Squid as part of your HTTP layer. Who here has heard of edge site includes? Couple people? Okay, so this is actually a really cool thing. Akamai helped spec this out. It is a standard, however. And what it allows you to do is to do partial caching on pages. So we run into this problem very quickly with full page caching if we have dynamic websites. So you can't return somebody else's cached version to the wrong person, right? So the idea behind edge site includes is that you can do caching on portions of your site separately from the rest of it. So there are many different ways to do this. It is supported by Varnish and Squid. Otherwise, I wouldn't put it in this talk. So you can turn off caching entirely. So for something that is completely dynamic, you can say don't cache this part of the page. You can have different TTLs for different portions. It can be per user session or maybe per geographic area. So for example, if your site is being delivered both here and in New Zealand, they're going to get maybe different imagery for different pricing, right? So things to think about. This is what it looks like. You have an ESI include, pull in this HTML segment. This is the personalized greeting. This is what the edge site include will try to include. And then we have ESI remove, and what this will do is this is a include for something that is way, way less resource intensive. So generic greeting. So maybe, for example, the first one says, hello, Joanna. And this one says, hi, right? And what will happen is if we are able to process the include correctly, then we will remove what's between those tags. Okay, so this is a fallback. Image compression. As I mentioned, image optimizations is the most important thing probably these days. And while designers have a role to play, we also can play a role. So you can do format negotiation. There are 2 new formats that are being pushed, WebP by Chrome, JPEG XR by IE11, and Edge. These are both better compressors in some ways, and for some things in, say, JPEG or PNG. You can dynamically convert images and store them, and then depending on the browser that's coming in, you can deliver the most performant version for them. Compression is a huge thing. Who has ever played with the JPEG levels? What do they mean? Nothing. It's completely up to the encoder. They get to decide what those mean. So yeah, you can't actually sort of say, I'm just going to have a 60% everywhere. It's not actually a percentage. But something that's really easy to do is JPEG levels. Now, one thing we can talk about is perceived quality. If you remember earlier, I showed you that image that looked terrible when we compressed it because we don't know exactly what the designer wanted. Perceived quality is this idea that it's quality humans can see, not quality machines can see. And so I think this is an animation. Let's see if it starts. No, this is what we had before. So this is compression level 100. This is the same image actually sized down to like 50 pixels and then back up because it's the only way I can make it look terrible enough on a slide. But obviously we as humans, we can see this looks pretty terrible. This looks pretty good, right? As computers, so 16.8 megs for the original, 90, 5.8 megs, 4.2. So these numbers, again, those JPEG compression levels really don't mean anything, but we can keep going down here. 30, 20, 10, 0. I actually can't see a difference in this one, even on my computer. So original, 0. Anyone see a difference? There's a little bit of artifacting. Move slightly because I'm terrible at slides. Maybe down here, maybe some JPEG artifacts. But that's a huge difference in size. Like the original was like 15 megs. This is 393K, right? But how do we dynamically make these changes? Right? How do we know where that compression level is that a user is going to start seeing the difference? Am I not loud enough?
No, this mic's not working.
Oh, well. All right, did someone say something? No? Okay, so we can use SSIM, structural similarity for images. Now, SSIM is a really, really cool algorithm. It is actually an Emmy award-winning algorithm. I did not know they gave Emmys for algorithms. Who collects that? I'm not sure. But it does have an Emmy. This is the algorithm. If you're good at math, that might not be complex. Thankfully, for me it is, and we're not going to go into it. Fact of the matter is someone else has written the code. But what it's based on is brightness, contrast, and structure. These are things that human eyes perceive, and it is fast, which is really, really important. What we can do is we can use DSSIM, which is the dissimilarity between two SSIM scores, to figure out how different two images are in terms of perceived quality. So we see the DSSIM scores up there in the top right, and then this is like a heat map for how much the image changes. So I'll go through it one more time. So this is the 90. You see, ever so slightly, we're seeing more and more noise introduced. So what we can do is we can decide what our threshold is for that similarity score. And we can actually tweak that. We can say for users in India, where internet is not so great, maybe we're okay with that dissimilarity being greater so that we can get greater compression. Right? We can do geographic changes, things like that. Mobile's another great one. So for example, taking that image, at 90, I get a DSSIM from the original of 009, going through all the way down to 0. And I may say that 0.02, that's my cutoff. So I know that somewhere between 30 and 20 is my magic number, and we're just going to do it in tens because that's easy, right? And that's the one that I will then store. So I will compress it at every single one of these levels to see where the dissimilarity is too great, and then store that one as my perfect one. All right. So set the perceptive quality threshold. There's the original at 14.1 megs. Here it is at 30. I know it's hard to see, but these look pretty much identical. And we save 91.4% of our bandwidth, which is kind of incredible, right? All right, who's a front-end developer? Thank you. You make me look good. Yeah. So for you guys, predictive browsing is super cool. It's also known as pre-browsing. And what pre-browsing is the ability to inform the browser of actions that are going to happen on your user's behalf. So you can do things like prefetching of DNS or pre-connecting TCP connections. You can prefetch, which means to grab the resource, and you can actually pre-render. So you can actually take it off screen and render it in its entirety. So that when they then request that resource, it's already rendered. So here's a browser. This is DNS prefetch. So you say to the browser, we are going to be looking up probably this domain next. So go ahead and do the DNS fetch now. Then you have the TCP pre-connect. So we say we're probably going to connect to this server next. So let's just go ahead and connect to it. We'll leave that connection open until we need it. Preloading, just grab the content, just stays in memory. Don't do anything with it. And then finally, actually render it off screen, store it, so that when it's needed, it's already done. And pre-render is actually really important for like whole page transitions, like an animation that's starting to happen on the web. That's how that's performed. So DNS prefetching, really simple. Link, rel, DNS prefetch, href, and you'll notice there's no protocol here because it's DNS. We don't have protocols, it is DNS, so just example.org. That will tell the browser to go and resolve example.org. Oh, I didn't know I had animations there. Very similarly, pre-connect. So literally change DNS to pre-connect. This time we need protocol, and we will just go ahead and open a TCP connection and do the SSL handshake to example.org. Prefetch, again, just change that rel. Now this time, we can use the relative URL, so it could be on the same domain. And pre-render, again, pretty similar. Really, really important for you to take note. Of course, we're all going, we've got so much internet, and we know they're going to have all that time. Let's just pre-render everything. You have to render the entire page, which means you have to fetch all of the sub-resources. So when your page loads and that link tag comes in, it's going to start fetching all the sub-resources for the pre-render stuff, which is potentially going to contend with the sub-resources for the current page as well. Plus, it could be huge because web pages are huge these days. There's another spec, rel preload, and what preload will do is it will tell the It's very similar to prefetch, which is why I have a slide on it. All right, here's the difference. Prefetching is about the next action. This is what the user is going to do next. It is intended to be something that is optional and not high priority. Preload, on the other hand, is about the current page. So for example, you may tell it to preload the CSS, or more likely the font for the CSS. Right? So if you can load the HTML page, have the link tag for the CSS file, have a preload for the fonts, it means the browser can start downloading the fonts before it has finished downloading the CSS or before it has finished parsing the CSS. So preload is typically sent as a header. It makes more sense at that point. It is also used for server push. So this is what it looks like. Link the resource rel equals preload. I don't like that we're using it for server push. So the idea is that the Nginx or Apache or WSGI or whatever would see that header from the responding application, and it would then do a server push to the client. And it would remove the header. The browser would not actually get it. My problem with this is that you are loading two different mechanisms behind preload. And I argued for this with the group that maintains this stuff. And they said, no, it's fine. In every case, you can do either. And then they decided to add a no push flag that goes here, just in case you don't want to push it. So I'm going to go back and re-argue for that. But for now, this is the way that we're also doing push. What this does is it opens us up to new architectures. And H2 also opens us up to some really great architectures. So HTTP 1 sucks. Sorry. We have come up with a whole bunch of really clever hacks to make HTTP 1 not suck so much. Minifying concatenating JavaScript and CSS, for example. Inlining small JavaScript and CSS is known as critical path. Using image sprites. Who's used an image sprite? How much of a pain are those to handle? Like you've got gruntass on gruntass to manage that. And then we have data URIs, we have domain sharding, all of these things to make HTTP 1 not suck. Sorry, I need a drink. Yeah, should have preloaded. Is anyone not familiar with domain sharding? So domain sharding is this idea that browsers have an artificial limit of only loading 6 connections to any given domain. So if you have 15 images, it will make 6 requests and then 6 requests and then however many's left, 3, right? So domain sharding, you use subdomains for the same server and you just split it out. So you'd have s1.example.org, s2.example.org, et cetera. And it would make 6 connections to each of those. So they're all very clever, certainly far more clever than I could come up with. But they're all hacks and they take time. Multiplexing is something that we get for free with H2. And multiplexing is this ability to send many, many requests over a single TCP connection. And it also allows us to do server push. We do dependencies, which is really cool. It allows us to say, I want to send this resource, but don't bother sending it until this other resource has been sent. Great example, fonts for your CSS. Send the CSS style sheet before sending the fonts. Right, that makes sense. We can also give things weights. We can, it's sort of an arbitrary thing. You say, it's a number between 1 and 256. You say this one weighs this much in terms of importance, and this one weighs this much in terms of importance. So something with a weight of 1 is essentially the least important thing, and something with a weight of 256 is 256 times more important, whatever that means in the connectivity environment that you are in. So the browser and the server will sort of negotiate how many resources to dedicate to each individual stream. So if we look at a page today, what we can do now is open up a TCP connection. We can do a simple get and get a response. This is what we do right now. In H2, we can also say, I also want to send all of these things. And I will proactively as a server just shove those down the pipe. So we send our critical path CSS and our critical path JavaScript. We're very vain, so we send our logo. We can do this instead of embedding them in the page, which is really important because by embedding them in the page, you can't cache them across pages. So we actually are saving bandwidth there. because you never know if they've got the critical path stuff. So by sending it as individual items, they can be cached individually, and we don't have to worry about that. All of the caching rules come into play. We can have a dependency, so send the font once the critical path CSS has been sent. Send our main JavaScript, so everything else. Maybe we send a splash image. I wouldn't recommend it, but again, we're vain. And then we can maybe send the rest of our styles. So the idea behind the critical path is it's just to render what is visible on screen when the page loads, and everything else can look like crap. So in summary, performance is critical. Time is literally money. But time is also user experience, which is more important. That's it. So I would love feedback and questions. And water. I can wash this around because we're going to have to share. We good for questions? I can just share. It's fine.
That's okay. So I was just going to ask about page load animations and how they affect perceived performance and any guidelines around minimizing that impact.
Sure. I'm assuming everybody else heard that. So humans are really special. Our brains are really, really clever, and they will fool us into thinking things are more performant than they are. And we can use things like loading animations to pretend that slow things are not slow. Animations are critical for perceived performance. You have to be aware, though, just like there's always that trade-off. How much resources does it take to prepare the animation? Could I better spend that actually doing the thing that I'm pretending that I'm doing? So, other questions? I'm just going to work my way back. Sorry, Jack.
So if you had like some large piece of data that you needed them to asynchronously fetch on a page based on their identity or something, and you wanted to use the prefetching sort of mechanism, how would you make sure they didn't already have a request in flight and you're giving it to them twice?
So this, there's kind of two answers to that. If you push something to a browser, they are the determining factor as to whether or not they receive it. So in H2, we would send a frame that says, I want to push you something, do you want it? And they would just ignore, they would say no if they already had it in flight or didn't want it. Of course, if it's dynamic, you're doubling your resources to generate it both times, right? That's unfortunate. We need to do better. We're all learning. I will go this way. I just didn't want to walk all the way back.
So specifically around weight of resources being pushed down the pipe, because that number between 1 and 256 is arbitrary based on implementation, browsers are notorious at being reliable and consistent in their implementation of that kind of thing. How do browsers currently handle it? Are we good, bad, ugly?
I was waiting for the question. Yes, so it's based on a whole lot of factors. The number one thing is that it is implementation specific. Just like the JPEG levels, those numbers mean nothing. And unfortunately, browsers today, their H2 implementations are technically correct in that they work, but they don't know enough yet to optimize. So you do get something for free. Like by using one connection, SSL overhead is basically minimal because you only do one handshake. So that's great. But things like weights, they're not there yet. Implementations of weights are not there. Having said that, this is not just about the web. If you are building your own API clients, for example, and servers, you can use all of these features there also. And then you get to control that. So bear that in mind. Other questions? Yes.
I was wondering how widespread and how well supported is HTTP 2 right now in web servers?
In web servers. Okay, so first of all, I will tell you about browsers, because I know that as a number. 60% of browsers currently in users' hands support H2. That's a great number. As far as servers, Apache supports it. Nginx supports everything but server push, so I hate Nginx. It did? They told me it wasn't on the roadmap. Okay, so maybe it's there. I actually don't know if like WSGI supports it, for example. I don't know the answer to that. So, yes.
So in the example you gave of different renderings, and for example, you said in India with slow internet connectivity, or what about the difference as well between a mobile or desktop in the same example of, from a CDN perspective, if I had rendered, say, 100% and I want to display it to a desktop, and then the 10% I want to display as a mobile, is that possible from a CDN rule, or where would I do that?
I can only speak for Akamai. Yes, it's possible. I don't want to advertise for Akamai, so that's all I'll say. But yes, it's basically generally geolocation stuff. It is certainly possible on the platform, and it's possible without the platform also. One other great use case for that is mobile, where people will transition from, say, Wi-Fi to being on their network provider. If you're writing like a native application that can detect those changes, you may decide that the server is going to push down, say, comments on a blog post. And if you are mobile, then you would just not accept those because you don't want the bandwidth usage. So nice use case there. There's a lot of dynamicism that we can start to bring in from both the client and server side. Any more questions?
We can take one more question.
Okay. But we don't have one, so that's fine. All right, thank you very much. Slides are up there.